In the previous video, we discussed about what is electric dipole, what is the definition of dipole, what is point dipole, short dipole, ideal dipole, and I've mentioned that even though net charge is zero, electric field due to dipole is not zero, right? So now we will calculate the electric field because of a dipole. Clear? Okay. See, electric field due to a dipole on the axis. We'll find the electric field along the axis, along the equator, and a point which is neither on axis nor on equator. Clear? Okay. There is a dipole placed along Z, right? This is the center of the dipole. It lies at the origin. Now, what is a dipole? System of two equal and opposite charges separated by some finite distance of 2a. I have explained the reason of 2a also, right, in the previous video. Okay, now we want to find electric field at a point P, right, which is along the axis of a dipole. And dipole moment is a vector quantity which is being directed from minus to plus. So this is the direction of dipole moment. Okay. Now say the point P is at a distance Z from the origin. Clear? Okay. So if this is Z, this is A, and this will be Z minus A, right? Okay. And similarly this will be Z plus A, because this is Z A. This will be क्लियर, ठीक है. ओके, डाइपोल मोमेंट की डायरेक्शन क्या होगी? नेगेटिव से पॉजिटिव. पॉजिटिव चार्ज की इलेक्ट्रिक फील्ड उससे दूर रहेगी, ठीक है, और नेगेटिव चार्ज की इलेक्ट्रिक फील्ड उसकी तरफ आएगी. दैट मीन्स द इलेक्ट्रिक फील्ड बिकॉज ऑफ द पॉजिटिव चार्ज एट अ पॉइंट पी विल बी इन दिस डायरेक्शन, राइट? इलेक्ट्रिक फील्ड ड्यू टू पॉजिटिव चार्ज, and electric field due to negative charge will be towards it, right? But as this charge is at a farther distance, so the value of electric field because of negative charge will be somewhat less. Clear? See, positive charge is placed closer to the point P, right? So its electric field will be in this direction, away. Negative charge, its electric field will be towards, but it is at a farther distance than positive charge, right? So the value of electric field because of negative charge will be somewhat less. Okay. So net electric field will be definitely in upward direction, right? So net electric field and dipole moment, net electric field and dipole moment both are in same direction. You're getting the point? Once again, I'll repeat. Positive charge, right? We want to calculate the electric field at this point, right? Okay. So positive charge, the value of the direction of electric field because of positive charge will be away. Direction of electric field because of negative charge will be towards. Clear? But since positive charge is at a lesser distance, so the value of electric field because of positive charge will have greater magnitude. Clear? So net electric field will be towards the electric field of positive charge. Okay, so the direction of net electric field will be in Z direction, positive Z. So dipole moment, the direction of dipole moment is from negative to positive. So direction of dipole moment will be also in upward direction. That means angle between dipole moment and net electric field will be 0 degree for a dipole placed along the axis. This can be asked as an MCQ, right? That when a dipole is placed along the axis, then what is the angle between net electric field and dipole moment? Then the angle between them is 0 degree. Okay. Okay, now let us find the value of electric field, the formula to calculate electric field. Clear? Okay. We've seen that electric field because of a charge Q is KQ by R square, right? Okay. So electric field because of positive charge will be KQ upon the distance. This is Z, this is A, and this distance will be Z minus A. So KQ by R square into unit vector. Unit vector is to show the direction of electric field, right? And since we are discussing the electric field of a dipole, I am representing it with the help of a dipole moment. Okay, now electric field because of negative charge will be k q by z plus a the whole square into p caret, right? Minus kq by z plus a the whole square, because negative charge is at a distance of z plus a. This is a, this is z, so the total distance will be z plus a. So finally the net electric field will be electric field because of, we can use superposition principle, electric field because of positive charge plus electric field because of negative charge, right? So it is finally kq by z minus a the whole square minus kq by z plus a the whole square into p caret. P caret is to show the direction. Clear? Okay, so now net electric field equals to kq 1 by z minus a the whole square minus 1 by z plus a the whole square into p caret, right? This term will go over here, this term will go over here, so it will be z square plus a square, z square plus a square plus 2za minus z square minus 2za plus a square. So the middle term will be remaining, other terms will get cancelled. So finally it will be 4za, 2za plus 2za upon z square minus a square the whole square, right? A minus b, a plus b, that is a square minus b square square. Okay? Okay, now what is dipole moment? So dipole moment, clear? So this is your net electric field because of a dipole along the axis. In terms of dipole moment, if you are supposed to write, then you can write P is equals to Q into 2A. This is dipole moment. So I can write it as I'll place 4 as 2 over here and 2 this way. Now, but what is Q into 2A? Q into 2A is P. So finally, net electric field will be 2 kp z upon z square minus a square the whole square p caret. This is a final equation for the electric field along the axis because of dipole. Clear? Okay, we can discuss one more point. Okay, what if z is greater than a, right? That means the point P is very far away from the origin, right? Then you can say z is greater than a. Okay, z is greater than a, then a can be neglected. So for this special case, electric field along the axis because of dipole will be 2 kpz upon, you can neglect a square, right? So it will be z square the whole square, that is z raised to 4. So it will be 2 kp by z cube. So electric field for a dipole along the axis at farther distance will changes as 1 by r cube and not as 1 by r square. This is a very important point. Use this formula if it is mentioned as in the question, if it is mentioned as it is a short dipole, or if the condition is being given to you. Clear? So this was a derivation of electric field because of dipole along the axis. Okay, now let us find the electric field because of dipole on the equator, and then we'll discuss few sums based on this topic.